Hi guys, my name is Krishna, and today I will talk about the difference between mass moment of inertia and area moment of inertia. So what is inertia? What comes to mind when you're thinking about it? In the simplest terms, inertia is a characteristic of an object to resist changes to its current state, be it geometric or motion related. So it is not to be confused with momentum, which is a measure of how much kinetic energy an object possesses. So let's review the basics. Force is any interaction that will change the motion of an object when it's unopposed, that is. So force, intuitively, we call it a push or a pull, and it causes translational motion. Moment of force, and often we just call it the moment, is a measure of force's tendency to cause a body to rotate about a specific point or axis, and moment causes rotational motion. So we define force to be mass times acceleration, and when we solve for the acceleration, we get force over m. And we see that mass is inversely proportional to the acceleration, so we can say that mass causes resistance to translational motion. Analogously, if we look at rotational motion, moment is equal to some formula which is analogous to the mass here, and angular acceleration. So when we solve for angular acceleration, we see that that value is inversely proportional to the angular acceleration. And so this value, we call it mass moment of inertia, and which causes resistance to rotational motion. So mass moment of inertia is rotational analogous to mass. So now let's talk about mass moment of inertia. So the tendency of an object to resist its state of motion with respect to its mass is defined as mass moment of inertia. So let's look at this figure. There's a rotational axis here, and here is the mass differential, and r is the perpendicular distance between these 2 points. And to derive the equation for mass moment of inertia, we take the integral of r squared with respect to the mass differential. It is important to note that this value is relative to the axis it is calculated about, which means that if this rotational axis is positioned here or here, the value of mass moment of inertia will be different. So here we see the equations for mass moment of inertia of different objects at different axes of rotations. Now, we know that mass is equal to density times the volume of the object, and volume is equal to the height times the area of the object. So if I replace this mass with the equation of mass moment of inertia, I can write this equation as density times the integral of r squared with respect to the differential volume. And analogously, I can write this equation as density times height times the integral of r squared with respect to a. And this term is called the area moment of inertia. So area moment of inertia is the resistance to change in an object's state with respect to its geometry. Therefore, we usually see it in formulas such as deflection and bending stresses, where forces are trying to change the geometry of the object. So here are some examples of equations to calculate the area moment of inertia of different geometries. So now let's review some terms. So the first row deals with translation motion, and the second row is for rotational motion. We see that force is analogous to the moment. Translational displacement is analogous to angular displacement, and similarly, mass in translation is equivalent to mass moment of inertia in rotation, and area in translation is analogous to area moment of inertia in rotation. Finally, I have some links that show the physical demonstrations of area and mass moment of inertia. These links can be found in the description of the video. Thank you.